Alright, we're going to solve the next exercise. Exercise is number 1.29. The planet Neptune has an equatorial diameter of 49,532 kilometers, and its mass is 1.0247 times 10 to the 26th power kilograms. If the planet is modeled as a homogeneous sphere, what is the acceleration due to gravity at its surface? The universal gravitational constant is G equal to 6.67 times 10 to the minus 11 Newton square meter per square kilogram. Now, I'm going to write down the information that I need for solving the exercise. So it is telling me that the diameter of the equatorial line of Neptune is equal to 49,532 kilometers. Neptune has a mass of 1.0247 times 10 to the 26 power kilograms. If the planet is modeled as a homogeneous sphere, so here I have my first assumption. A sphere. What is the acceleration due to gravity at its surface? So they are asking me for G, and they are asking me to they are telling me that the universal gravitational constant is equal to G, which is equal to 6.67 times 10 to the minus 11 Newton square meter per square kilogram. Now, when they are talking, I've looked for a sphere image right here. When they are telling me that the equatorial line has a diameter of x value, they are telling me that this diameter is equal to that value. Alright, because I am assuming that the planet is spherical. Now, because of this, I am going to explain first the principal concepts that are needed to be taken into account in order for us to solve the exercise. So, when I have two particles separated by a specific distance, which I am going to call r, and that particles have a mass of m1 and m2, m1 for the first particle and m2 for the second one, it is going to be generated an attraction force, which is going to be the same for the two particles. Now, Isaac Newton said that that force is equal to the gravitational constant multiplied by m1 by m2 divided by the distance between them to the second power. Now, because we are talking about gravitational forces, it is pretty common to talk about planets. When I have a planet, and on the surface of that planet I have a specific particle which I'm going to call it I am going to call P. The center of that planet is going to pull the particle. Now, because of this part of the equation could be rewritten. Now, the force that is attracting the particle to the center of the planet is going to be equal to g multiplied by the mass of the particle multiplied by the mass of the planet, which in this case I'm going to call it mn in the case of Neptune, divided by the distance between them, which is the same as the radius of the planet, evaluated to the second power. Now, because of Newton's second law, which is a force is equal to a mass multiplied by an acceleration, I could rewrite this part of the equation. Now, a mass of the particle multiplied by an acceleration of the due to gravity, the acceleration due to gravity, is equal to g p n divided by r to the second power. Now, because of these two values are the same, I could and I will eliminate the I will eliminate both of them. Now, the equation at this point will look like this. So at this point I have g, yes I have g, I have mn, yes I have mn, I have r2, I don't have r2 but I have the diameter, so I just gotta evaluate the diameter divided by 2, which is the same as having the radius of the planet, and I'm looking for an acceleration, and this acceleration is the same as this one, the acceleration due to gravity. Now the answer will be g is equal to 6.67 times 10 to the minus 11 multiplied by mn, which is 1.0247 times 10 to the 26th power, divided by 49,532 divided by 2 because it's the radius to the second power. Now, how do I know if this equation is correct? My method is by applying the same equation but to the units. Alright, now transforming those into the units, it is going to be equal to to Newton multiplied by square meter per square kilogram, right? Right here I have the units of this. Multiply it by the units of this, which are kilograms, divided by kilometers to the second power because of these two. Kilometers to the second power. Now I am going to transform these newtons into a more simply way to analyze it. So because of these newtons are a force that is equal to a mass multiplied by an acceleration. So because of we are talking about international system units, then that mass is equal to a kilogram and that acceleration is equal to a meter divided by square seconds. And then I just have to complete all the units left. Now right here I have the newtons, right here the meters, right here the kilograms, these kilograms, and these kilometers. Now I'm going to eliminate these kilograms with this these kilograms with these 2 kilograms, these kilograms with these kilograms, and the answer will be meters to the third power, because I'm multiplying these two divided by square seconds, and that divided by square kilometers. So that is the same thing as having meters to the third power divided by square seconds, and this is divided by kilometers. And I could assume that these kilometers are divided by 1, right? Because if I divide by 1, I'm not doing anything, but that works for me to understand this operation of units. Now, for those of you who didn't understand what I did here, I'm going to repeat. I am eliminating these kilograms with these two, because right here I have two of the same unit, which are the kilograms. Then I'm going to eliminate this with this, and I'll have the answer of multiplying meters by square meters, which are meters to the third power, divided by square seconds. Now I'm going to apply this law, in which I am going to multiply the numerator part of the first division. I call this the first division, with the denominator part of the second division. And I'm going to do the same thing here with these two. Now, those are not the units I'm looking for. I am looking for the unit of the acceleration due to gravity. So if I am talking about international system unit, it should be meters per square seconds. But right here I have meters to the third power and kilometers to the second power. So if these kilometers were not kilometers but were meters, I could eliminate 3 of these meters with these 2, and I would have the answer that I need. But this is not the case, so this is giving me, or this is telling me, that I am not going to do a good I am not going to get a good result by doing this. So the answer is to transform these kilometers into meters. How do I do this? By just writing down the equivalence of the prefix. Now, if I talk about units prefixes on Google, I am going to find this chart. I don't like it. That doesn't look so good. Now, I'm going to find this chart. You see, I've looked for units prefixes. This chart is going to give me the equivalence between a lot of prefixes and their symbol right here, and the multiplying factor. So parentheses here, you gotta memorize this chart, or at least that's the thing that I did, because I've memorized all the prefix. I've know what is the symbol for the correspondent prefix, and right here for the value I've memorized it as follows. Right here I have like the equator, like the middle line. So on the upper side of this line I'll have 1, 2 and 3, and starting from that point I'll just have to add 3 by 3, so 6, 9, 12, 15, 18, 21, 24, etc, etc, etc. I don't know if there is more. I actually have memorized until this one. And on the below part of the line it is going to be the same thing, but with a minus. So -1, -2, -3, and starting from that point, -6, -9, -12, -15, -18, -21, -24. Alright, close parenthesis. Because of this, when I look for the K, which is for as for kilo, it is equal to 10 to the third power. So I gotta multiply this by by 10 to the third power for it to stop being kilometers and start being just meters. Now if I put that on the calculator, I'll have something like this: 6.67 times 10 to the minus 11 times 1.0247, sorry, 1.0247 times 10 to the 26th power divided by 49,532 times 10 to the third power divided by 2, and that is evaluated to the second power. Then the final result for G is equal to 11.1432. I always use 4 significant digits after the comma or the point, meters per square seconds. And that's, guys, how this exercise could be solved.